Okay, this is a surface area question. One that I was doing in class that I said I would record for you guys and before class ended, and here it is. So find the surface area generated by revolving the curve y equals the square root of x plus 2 for x is between 0 and 4, and you're going to rotate this about the x-axis. Since y is given to you as a function of x and you're rotating about the x-axis, rotating about the x-axis puts a y in for the radius, but you can't have that y in there because you're not going to do the integral in terms of y. You're going to do the integral in terms of x. And so when they disagree like that, the y gets replaced by the f of x. So we rip out the f of x and we put in our function, square root of x plus 2. As far as the next piece that's there, also in the integral, we're just going to go off on the side and figure that out. We have the square root of x plus 2 as our function, and we want to take its derivative, 1 over 2 square roots of x plus 2. Then we want to square it, so 1 over 4 quantity x plus 2. Very important you write it like that. Don't distribute it out. Leave it just like that. You'll see why. Whenever your derivative squared is a fraction, you go to add 1. You want to make sure you add 1 by adding it as the denominator over itself. So then you can combine them into one fraction. 4x plus 8 plus the 1 gives us a new numerator of 4x plus 9, and the denominator is the same. Next up is to take a square root. It's a fraction on the right-hand side, so you take the square root of the top and the square root of the bottom. Now, there's nothing you can do to fix the numerator, but in the denominator, it's a product. In a product, you can split up the root. So I have root of 4 and root of x plus 2. So we'll have a 2 root x plus 2 in the denominator. This is our replacement to what's inside the integral. So we'll put that in, and magic happens. We have the x plus 2 underneath the root from the f of x, and the x plus 2 underneath the root in the denominator from the side work we just did about trying to find 1 plus y prime squared square root, and they cancel. Even the 2's cancel. Let's get them out of there too. Turns out then we are just integrating pi times the integral of the square root of 4x plus 9 from 0 to 4. This will give us our surface area. We'll do that on the next slide. If you can do this without a u sub, that's great. I have it here done with a u sub. So let's let u be equal to 4x plus 9. What's underneath the square root there? So that way we will end up with a square root of u in that spot. But there's an extra factor of 4 we have to account for. If you just know that you're going to divide by it, then you can skip this and just divide by it. Here's why you have to divide by, because this derivative is 4 dx. The replacement to dx is 1/4 of du. I think the limit switch is harmless. Let's go ahead and do it. So x is equal to 4 for the upper limit. 4 times 4 is 16. 16 plus 9. Your new upper limit is 25. And then x is equal to 0 for the lower limit. And that's just going to be u equals 9. So nice little change of variables, and we now have a simple integral. We have the square root of u integrated from 9 to 25 and a multiplier out front of pi over 4. Okay, antiderivative of u to the half is u to the 3/2 divided by 3/2 or multiplied by 2/3. And then the 2 can cancel the 4, turn it into a 2. The 2 and 3 can become a 6 in the denominator. You have pi over 6 on the outside, and then you put the 25 in, and you put the 9 in, and you have to raise them to the 3/2 power. How do you raise 25 to the 3/2 power? You take the square root of 25, and then you cube it. Same thing for 9. Take the square root of 9, and then you cube it. And so we'll have 5 cubed, 125, 3 cubed, 27. We subtract them. We get 98 pi over 6. And hopefully recognize that they're both even, so at least we can factor out a 2. Final answer, 49 pi over 3. Good work.